Hi everyone. In this video, we are going to learn to solve quadratics, and we're going to use factoring to do that. By the end of this video, you should see why factoring is useful, and that's giving you the ability to find zeros of quadratic. And another word for a zero is you're finding the x-intercepts of quadratics. Okay, so that's why we're going to use factoring in this particular video. So what I want you to do before I teach you the new stuff is I know you all know a lot about factoring. So for the 5 problems you see here, I want you to pretend this 0 isn't here and just factor each polynomial like you would have before we were solving. Okay, so take a minute, go through and do that. I'll come back with the answer. No cheating. Make sure you pause it and do it on your own. It's good practice. I went through and factored them all. I have not solved yet. I did go back in and set them equal to 0 because that was the original problem. But otherwise, I just want you to scroll through and check your factoring. And if you have any questions, please come and see me since we've already done this. So the first one was a difference of perfect cubes. The cube root of 8 is 2. The cube root of x cubed is x. Cube root of 27 is 3. So I followed that pattern. Remember, same, opposite, always positive. And this is what you should get. The second one, I threw you for a little loop here. I'm curious to see if any of you picked up on this, but you actually would need to move the 40 over to the left first to put it in standard form before you can factor. So I subtracted 40 from both sides and got it set equal to 0. Then I was able to factor by grouping. So I factored this group, pulled out the greatest common factor, then separately factored this group, pulled out the greatest common factor, and then I rewrote them here. If you got this far, one of the most common mistakes is not to factor completely, so I wanted to leave this to do with you. Since this one is a quadratic, it's got a square, this one can actually be factored further. This is a difference of 2 squares, because 4x squared and 9 are both perfect squares. So this factors into 2x minus 3 and 2x plus 3. Okay, so I can then rewrite it like so. Okay, other one, number 3 is basic factoring, what multiplies 15 and adds to -8. Same thing, but there's a coefficient greater than 1, so it makes it a little bit trickier because there's more combinations. Again, just check through your factoring. And I gave you a challenge on the last one where I recommend doing a u substitution, where u is the square root of x, so that would be 6u, and then square root of x squared, right, is equal to x, so that's why this is u squared here. Just remember, if you do a u substitution, to substitute the original back in at the end, and you get this factoring. Okay, so that was a brief review of factoring, testing yourself, of course, so if you have any trouble, please come see me. The point of this particular video is to learn how to solve quadratics with factoring. So there are 5 problems here. I'm going to focus on the one that are actually quadratics. So in order to be a quadratic, we have to be a second degree polynomial, which would be only number 3 and number 4. So we're going to talk about how to solve these, and the good news is how you solve quadratics would apply the same to how you solve any sort of polynomial, such as, this would be a cubic polynomial because it has a 3rd degree. It'll work the same, but for this video, we're going to focus on quadratics and use the other ones as an extension. Okay, so in order to solve quadratics, you're solving when it's set equal to something. And the first thing you want to make sure when you're solving is that it's set equal to 0. Because like I said, when you're solving for x, you're solving for x-intercepts. Okay, you're solving for its zeros or its x-intercepts. Okay, and when you have an x-intercept, that's where it crosses the x-axis, like here, and its y value at any x-intercept is going to be 0. So what this really says, you have the function f of x equals x squared minus 8x plus 15, and it's saying f of x is 0 means when is your y value 0, what is your x value? So that's why you need to get set equal to 0, is to be able to find the x-intercepts where y is 0. Now, for a moment, I want to pause on this problem and take a look at this problem. Okay, if you have any number and you multiply by another number, how would you get 0? Or a times b equals 0, what would have to happen? The only way you get a product of 0 is if either of the 2 items that you're multiplying is 0. So either a would have to be 0 or b would have to be 0. Okay, 0 times anything is 0, vice versa. This is called the zero product property. You may have heard of this before, but if not, here it is now. The zero product property just says in order to get a product equaling 0, either one or both pieces needs to equal 0. Why does that matter? So here you have a product. You're multiplying this term by this term, and their product is 0. So what would have to happen is either this would have to equal 0, or this piece would have to equal 0. So we want to figure out when that'll happen. And you might be able to see this without doing the work, but it's important to figure out how to do the work for when the problems are more difficult. So bear with me. So one of two things either needs to happen is that x minus 5 would need to equal 0, or x minus 3 would need to equal 0. And now we have equations we can solve. So if I add 5 to both sides, you would get x equals 5. Same thing if I add 3 to both sides. To get x by itself, you would get x equals 3. Okay, what that basically means is if you plug 5 in here, you get 5 minus 5, which is 0. 0 times anything is 0. Same thing will happen with 3. 3 minus 3 is 0. 0 times anything is 0. So that means x would either have to be 5 or 3 to give you an output of 0, or a y value of 0. So your x-intercepts, if you want to write them in another form, are 5, 0 or 3, 0. Okay, there's 2 x-intercepts in that particular problem. Okay, so pretty much you're going to factor these problems if you can, and if you can factor them, then you can use the zero product property to solve. So let's apply that to this one. You know, you might even look at this and say, I know I need to plug in 2 to get 2 minus 2 is 0, and that'll work. But it's helpful when you have something like this to actually go set it up and solve it. So let's do that. Either 3x plus 4 would need to equal 0, or x minus 2 would equal 0, or both of them could equal 0. So solve that. We're going to get x by itself. I'm going to move the constant to the right. And that would be negative 4. And divide by 3. And you get x equals negative 4/3. Right? While you can see that without solving, it's a little bit more difficult than solving this one in your head and saying, I know x would need to equal 2. Okay, again, this one would have 2 x-intercepts. I cannot stress enough that the reason we're practicing this skill is so when we graph functions, we can find the zeros or the x-intercepts. Okay, so both ways to write it are fine, but you have 2 different options there. Okay, so those are 2 quadratics. The other functions are not quadratics, but they're good extensions of how you can use factoring to solve. So for something like number 2, even if you have 3 things being multiplied, the same rule still applies. So either 2x minus 3 would have to equal 0, 2x plus 3 would have to equal 0, or x plus 5 would have to equal 0. So in this case, instead of having, at most 2 x-intercepts, you could have 3, which makes sense because this is a cubic function. And a cubic function could pass through the x-axis 3 times. Okay, I'm not going to do all of these in detail. I just wanted to give you a variety of examples. So here's another example. Again, it's not a quadratic, but we can still use that zero product property. Either the square root of x plus 3 would have to equal 0. Well, this is repeated factors, so you're going to get the same result, but let's just prove that by solving. So you get square root of x equals negative 3. To undo the square root of x, you would square both sides, and you'd get x equals negative 3 squared, which is 9. Same thing here. We'll talk more later about what it means when you get 2 of the same factor, but for now, after watching this video, you should just be able to solve for x-intercepts by factoring, okay, particularly for quadratics in this unit. If you have any questions about factoring, please come and see me. Otherwise, have a good night.